I'll show you where I'm going to post them here in after this is done. Anyway, here we go. What is a computer? What good are they? Really, we're just going to answer the first question. We're not going to spend all the time on the second one. Oh, I'm on the wrong screen here. Why isn't it? Anyway. So some vocabulary words that we'll look over: computer hardware, CPU, memory, software. What is an application? What is an input-output device? What is an interface? We're going to look at all of these. All these will come up. Some questions. We want to figure out what are the main components of a computer. What is an interface and what does that mean, and how does it work? What is the difference between hardware and software? What are the main kind of layers of a computer system? Who is John von Neumann and why is he important? And what is an input-output device? Okay, so first let's divide things into hardware and software. Hardware is the bare metal, the actual physical components that make up a computer. It's the copper wires running through everything, little gold contacts, silicone chips, all that stuff is the physical components that you can actually touch and feel. Software is a little different. Software is the something you can't touch. It's something you can't feel. It's the code that's running on the computer. It's electrical signals. That's all it is. It's just electricity and wires flowing in a certain pattern, a very complicated pattern. Throughout the course, we'll look at two different categories of software. Operating systems like Windows, Mac OS, Chrome OS. We'll even talk a little bit about some mobile operating systems here and there, partly just as a matter of course because they come up all the time, and partly because it's useful to know a little bit more about it. And then applications. And applications are things like word processors, spreadsheets, video games, web browsers, stuff like that. Stuff that we interact with as humans. Because the stuff is useless if it doesn't have some way for humans to interact with it. So this is kind of like the sort of layer model. I usually like this thing arranged vertically, but this is how PowerPoint wanted to do it, and I couldn't find a vertical version of it. At the very base, you have the hardware layer. That's, again, at the very bottom. And then a step above that, you have the operating system. And a step above that, you have applications. And then finally, you have you. You are part of the computer system because the computer system is useless without you. It doesn't do anything for anybody unless there's a user. So between each of these, in this area right here, let's just switch over to the pen. Here, here, and here are the interfaces. So the hardware layer interfaces with the operating system layer. So the operating system tells the hardware how to be a computer. The computer is if it's just a paperweight without the operating system. So the operating system interfaces with the hardware at a very, very low level. And then applications like Microsoft Office, that interfaces with an operating system right here. It's like people who program operating systems create what are called, they create interfaces so that people who are programming apps for actual humans to use, they create these interfaces that make it really easy to program. It's actually a lot easier to program a computer than it used to be in like the 60s. And then of course there's interfaces here for us to like interact with the app. So like here I have PowerPoint open. I've got like all these little, like I have a laser pointer that I'm pointing at with this little stylus here on this little drawing tablet. I can point at things using this this is an interface device. I have a screen that I can look at. I have headphones that I can hear you guys if you talk. I have, I have ways of interfacing with the computer. And if I didn't, then the computer wouldn't be useful to me at all. So all of these levels of functionality of this system, they are only useful insofar as there's ways for them to interact with each other. So we think of an interface as the point at which two systems intersect with each other, where they interact with each other. So computer architecture, generally today, almost every computer in existence today follows what we call the von Neumann model. John von Neumann came up with this idea of how a computer works, and he expanded on kind of the work of Alan Turing and his like really simple, rough idea of what a computer looks like. And I'll talk about Alan Turing a little bit when I do the history talk. I only talk about history for a little bit, for like one day, so it's not a huge part of the class, but I do think it is important to know the context. So von Neumann's theory was that this is a computer, is this part right here. The CPU and the memory, what we call, the processor and the RAM is kind of the modern terms for it. Oh, that's not, that was the pen. Yeah, so the CPU and the memory module, those are the computer. What's the next one? Yeah, so the core of the computer is the CPU and the memory module. These two things talk to each other constantly. There's always communication happening between these two things. The memory unit has the operating system all loaded up, and so it processes things. If you open an app, it gets loaded into your memory unit, like your web browser or a video game or something. It gets loaded into the memory module, and then it sends instructions to the CPU to like make things happen, have explosions appear on the screen, play music, whatever it is, listen to Spotify, I don't know, whatever it is. All of that is facilitated by a constant flow of information between the memory module and the CPU. The memory module is like the part of your brain, if you want to use like a brain analogy. This is the part that's doing the thinking. This is the part that stores the stuff that you're thinking about right now. So like this is what's going on right now. Your childhood memories are stored somewhere else. They're not here. That's long-term memory. That is not part of the core processing part of the computer. Yeah, so every other aspect of the computer, according to this model, is an input or an output device. Input devices like this stylus, output devices like, well, what's an output device? Does anyone want to give me an example of one? I know it's like shocking to have to like unmute yourself and stuff like that. What's a way that I get information out of a computer, for example? You're muted, Raina.
Storage.
Well,
Yeah, I don't know.
Yeah.
That was my attempt.
How about this? What is that?
I can't see.
It's my
your phone.
Yeah, the screen, yeah. In fact, like on almost all computers, the screen is the #1 way that you get information out of a computer and into your brain, downloaded into your eyeballs. It's a little different if you're visually impaired, but then you just have some other version of a screen, headphones and a screen reader or something like that. And interestingly enough, on phones, the screen is not only the primary output device, but also the primary input device because it's a touch screen. So yeah, everything else, every other aspect of a computer is an input or an output device. So here we go. Here's a couple of examples. Some of them are the same. So this is a Venn diagram. So we have things that are exclusively output devices. We've got things that are exclusively input devices. We've got things that are kind of the same, like a router or a touch screen or a camera or a USB thumb drive, CD. So an input-output device is a device that creates an interface by which a human or some other machine can communicate with this computer. And thereby expand the functionality of that computer. That's what's cool about computers nowadays, what we call general purpose computers, is that you can add new features. Like I can plug in a pair of VR goggles and suddenly I can do virtual reality stuff. I can add this drawing tablet, and then suddenly I can draw with a stylus in a more natural way than I was ever able to before. That's the cool thing about these modern computers, is I can, as long as there's a free USB port, I can stick something else in there, and now I have something else that my computer can do. It's pretty neat. So input devices, output devices. Let's go back to this one, yeah, real quick. So yeah, we're kind of looking at so the basic rough idea of what a computer is, what the difference between hardware and software is. We'll maybe talk a little bit more about the relationship between the CPU and memory, but it's not super necessary for our purposes in this class. I like to get kind of a baseline level of understanding. These are the two primary devices that process information in a computer. The relationship between these two parts of a computer cannot be overstated. An application, and of course, the name of this class is computer applications. So I think that gives us a clue that this is kind of where we're at. This is what we're focusing on mostly for this class, is just the application level. Like, what are some of the applications out there? How do we use them? And how can they make our lives more interesting, I guess. And then the idea of interfaces. I use this word a lot because there's lots of different kinds of interfaces. In particular, there's input-output devices which allow us to interact with a computer. That's about it for this talk. So I'm going to stop recording.